Learn insertion sort algorithm. So before we start, what is sorting? Sorting is a technique in which you're given an input sequence of numbers and the output sequence is another sequence of the same numbers but in sorted order, either in increasing order or in decreasing order. Example 1, 2, 3, 1, 5, 10, 9900, etc. So before I show you how the algorithm works, I would like to show you how it is done in real life by using cards. So you can see there are 4 cards here, 6, 7, 3, 10. So we start with the leftmost side and we see the second card, that is 7. Now we check this if its value is lesser than the value on the card, on the left card. So 7 is not lesser, so it stays there. Then it's done, you move to the next card. Now 3 you compare with the card on its left, that is 7. It's lesser, so you swap it. You put 3 here. And again, now you check 3 with its left card. Is it lesser? Yes, you swap it. Now 3 is at its position. Now you move to the 4th card, 10. Now you check, is 10 lesser than 7? No, it's not. So it stays there. Now we've processed all 4 cards, so it is in sorted order. So this is how the algorithm works. Now we'll show you how exactly line by line the algorithm works. So we have this function insertion sort, which has an input array of numbers, which is indexed from 0 to n minus 1. So that you can see input 0 to n minus 1 and the output is a sorted array 0 to n minus 1. So let's see the first line. The first line says that from I equals to 1 to n minus 1. Like I explained in cards, you start from the leftmost and you see this, you start with the second card. So you start with the second card and you assign that to j. J is equal to I. Now while j greater than 0 and a of j minus 1 is greater than a of j, this means that while the current number is lesser than all the numbers to its left, you keep swapping. That's what this means. And you keep decrementing j. So basically if it was 1, 3, 2 and you're at 2, so it compares 2 with 3, it's lesser, it swaps. Then it sees 2 and 1. 2 and 1, 2 is greater than 1, so it stops. Now you'll understand better when I explain with an example. Yeah, so for example, let's take this array 5, 3, 1 and 4. So according to the algorithm, we start for I equals to 1 to n minus 1. So I is at 3 and j is equal to I. So j is also here. Now you compare while j is greater than 0 and array of j minus 1, that is the element to its left, is greater than array of j. You keep swapping and decrementing j. So you check 3 with 5. Is 3 lesser than 5? Yes, it is. So you swap it. So it's swapped here. And now j becomes 0, so you break out of the inner loop. And now I proceeds to the next element, that's 1. And now you compare 1 with 5. 1 is lesser, so 1 is swapped with 5. And j is decremented. Now again, you compare 1 with its leftmost, 3. Now 1 is lesser, so it's swapped again. And now j becomes 0, so you break out of the inner loop. Now you go to the 4th element. Now 4th element, you compare with its previous one, 5. It is lesser, so it's swapped. And then you compare with its left, that is 3. It is greater than 3, so you stop it right there. And now as you can see, all the 4 elements are processed and the array is sorted 1, 3, 4 and 5. So let's analyze the time complexity. How much time does it take? Let's analyze the best case complexity first. So best case happens when the array is already sorted in ascending order. How? Let's see an example. Let's take 4 numbers which are sorted 1, 2, 3 and 4. So as we have seen in the algorithm, we start with the second element and now we see that second element is greater than the first element. So there's only one comparison. So we have a comparison counter which counts the number of comparisons. So the number of comparisons is 1. Now we move to the next element here. And now we compare this with 2. This is greater again. So just one comparison. So you add. Next 1, 2, 3, 4. You take this and you compare with its previous. One comparison. Plus 1. So as you can see, the total number of comparisons is 3. So it's linear. So basically for best case, the complexity turns out to be of n. Reason why? Because since it's sorted in ascending order, every element on the right or every element will be greater than the element to its left. So the inner loop of the algorithm will not get executed at all. It'll just be false with one comparison. So that's how the best case complexity is of n. Now let's see what the worst case complexity will be. It's in descending order. Example 5, 4, 3, 2. Let's again have a comparison counter which has total number of comparisons. So we'll start with 4. So now 4 is lesser. So it has one comparison and it's shifted. 4, 5, 3, 2. Right? So 1. And now we compare next element, that's 3. Now 3 is compared with 5 and it's swapped. So it becomes 4, 3, 5, 2. Again 3 is moved and compared with 4 and it becomes 3, 4, 5, 2. So there are two comparisons. So 1 plus 2. Alright. So now you have 3, 4, 5, 2. Now you come to the last element. Now you have to compare this with 5, it's lesser. Then you have to compare with 2, again it's lesser. And then you have to compare with 3, again it's lesser. So there are 3 comparisons. So 3. So total number of comparisons becomes 6. Alright. So the sorted array becomes 2, 3, 4, 5. And total comparison 6. So as you can see, it is 1 plus 2 plus 3. It's sum to n series. And we know sum to n series, 1 plus 2 plus 3 till n, is nothing but n into n plus 1 by 2. So that is big O of n squared. So the reason why it becomes n squared in the worst case is because for every element, since it is lesser than the element to its left, it has to keep swapping, right? So if you go to the last element, it has to keep moving n minus 1 times. This has to keep moving n minus 2 times. This has to keep moving n minus 3 times, and this has to keep moving 1 time. So if you add all of these, it becomes sum to n series like we've seen here, and it becomes O of n squared. So that is insertion sort for you. Thank you.